Hello everyone. I'm Sangeeta studying in Sri Venkateswara College of Engineering, Bangalore from the Department of Computer Science and Engineering. Today we are going to discuss about a topic Introduction to Propositional Logic, which comes under Discrete Mathematics. Introduction to Propositional Logic. Propositional logic is a fundamental branch of mathematics and computer science that deals with the study of logical statements and their relationship. It provides a framework for analyzing the truth or falsity of complex propositions by breaking them down into simpler atomic components and applying logical rules and operations. Few logical operations are conjunction, disjunction, implication, negation, conditional, and biconditional propositions. Basic connectivities. There are basically three connectivities, which is conjunction, disjunction, and negation. Conjunction is nothing but the and statement. The conjunction connective joins two or more statements requiring that all of them be true for the overall statement to be true. It represents the logical and operation where the resulting statement is only true if all the individual components are true. The truth table for conjunction. Let us consider P and Q. P and Q. If both P and Q are true, then the P and Q is true. If any one value is false, then the conjunction value will be false. Disjunction. It is logically the OR operation. The disjunction connective joins two or more statements requiring that at least one of them be true for the overall statement to be true. It represents the logical OR operation where the resulting statement is true if any of the individual components are true. Here the OR operation takes place. Let us consider P and Q and P or Q. If P and Q are true, then the disjunction is true. If P is true and Q is false, then the disjunction is true. If P is false and Q is true, then P or Q is true. If P is false and Q is false, then the disjunction value is false. Only if both the values is false, then the OR statement is false, or else it will be true. Negation. It is a logical not statement where it is the complement of the one value. The negation not connective reverses the truth value of a statement, making a true statement false and a false statement true. It represents the logical not operation where the resulting statement is the opposition of the original statement. Here, P is the original statement where the value is true, and the opposite of the original statement, that is negation P, will be false. If P is false, then the opposition of the original statement, that is negation of P, is true. Conditional prepositions. A conditional is a logical component statement in which a statement P, called the antecedent, implies a statement Q, called the consequent. A conditional is written as P implies Q and is translated as if P then Q. So we'll see the truth table of the conditional preposition. Let us consider P and Q, and P implies Q. If both the values are true, then it is true. If one P is true and Q is false, then the output is false. If P is false and the Q is true, then the output is true. If both P and Q are false, then the output is true. Here, the output will be false only if the P is true and Q is false. Let us see an example for conditional preposition. We have a conditional statement. If it is raining, we will not play. So here, let us consider A as it is raining and B is we will not play. Then if A is true, that is it is raining, and B is false, that is we played, then the statement is A implies B is false. If it is raining, we played, it is a false statement. So A implies B is false. Only if the first statement is true and the second statement is false, then the output will be false. Otherwise, it will be true. Biconditional preposition. The biconditional statement P if and only if Q denotes P implies Q is true when both P and Q carry the same truth value and is false otherwise. It is sometimes abbreviated as PIFF if Q. Its truth table is depicted. So the biconditional truth table is, let us consider P and Q, P biconditional Q. If P, only if Q. So if P is true and Q is true, the output is true. If P is true and Q is false, the output is false. If P is false and the Q is true, the output is false. If P is false and Q is false, the output is true. Let us consider an example for biconditional proposition. I will eat lunch if and only if my mood improves. Only if P, let us consider I'll eat lunch as A and my mood improves as B. My mood will improve if and only if I eat lunch. If both the statements are true, then the output is true. If both the statements are false, then the output is true. Otherwise, it will be false. Next is tautology. Tautology is a condition where all the output values should be true. That is the main condition of tautology. We'll see the statement of tautology. A tautology is a statement that is always true, no matter what. If you construct a truth table for a statement and all of the column values for the statement are true, then the statement is tautology because it is always true. The famous saying, I cannot tell a lie, may come to mind when studying tautologies. Let us see an example for tautology. Let us consider P, Q, and the third column is P implies Q, fourth column is Q implies P, and the fifth column is P implies Q or Q implies P. If P implies Q, whenever the P is true and Q is false, the output will be false, or else it will be true. So the value for P implies Q is true, false, true, true. For Q implies P, whenever the Q is true and the P is false, then the output will be false. So the output of Q implies P is true, true, false, true. So if we do the OR operation for P implies Q and Q implies P, we will be getting true, 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 where all the values are true. Therefore, this is the best example for tautology. Contradiction. Contradiction is also a statement where all the output will be false. Contradiction is an assertion of propositional logic that is false in all situations. That is, it is false for all possible values of its variables. A contradiction is a situation or idea in opposition to one another. Declaring publicly that you are an environmentalist but never remembering to take out the recycle is an example of contradiction. A contradiction in terms is a common phrase used to describe a statement that contains opposite ideas. Here we have considered a truth table as an example for contradiction, where we have taken P, Q, negation of P, negation of Q, P or Q, negation of P and negation of Q, P or Q and negation of P and negation Q. If we consider this truth table, the output of this truth table will be false, 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 where all statements output is false. Then this is the example for contradiction. Next is contingency. It is a statement where it has a combination of truth and false in its output. Finally, a contingent statement is a statement whose truth depends on the way the world actually is. Thus, it is a statement that could be either true or false. It just depends on what the facts actually are. So, the best truth table for contingency is shown here. P, Q, P and Q, negation of P, and the output is P and Q implies negation P, where the output is the combination of true and false values. So, it is an example for contingency. Next is logical implication and rules of interference. Logical implication is the fundamental concept is propositional logic, where the truth of one statement necessarily leads to the truth of another statement. This relationship between the statement is known as logical consequence. The most common rules of inference include modus ponens, modus tollens, disjunctive, and hypothetical syllogism. These rules allow us to draw valid conclusions from given analysis. Techniques for proving theorems: direct proof, indirect proof, and induction. Conclusion and summary about the propositional logic. In this presentation, we have explored the fundamental concept of propositional logic, including the basic connectivities, truth tables, logical equivalence, and the roots of inference. We have also delved into the powerful use of quantifiers and the techniques for defining and proving theorems. These logical principles form the foundation for rigorous mathematical reasoning and serve as the basic building blocks for more advanced fields of study. Thank you.